Okay, so we're going to talk about Chapter 10, which is inference. And here's a definition of statistical inference. And I'll give you a second to copy that down. Just to let you know, there's two types of statistics. Now, up until now, we've just been talking about descriptive statistics, which is, for example, how to find the mean or the median of something, or, you know, what's the probability of an event occurring, or what proportion of something in a population. That's all we've had so far. Now we're going to do something with it. So go ahead and copy this down if you don't already have it in your notes. And then here is your problem. And I'll let you read it, but also read it to you. According to a survey performed by Real Estate Institute at USC, the sample mean rent in 2003 was $1,300 for Los Angeles County. Assume the survey sampled 250 rents in Los Angeles County, and also assume the standard deviation in rents was $350 for Los Angeles County. Calculate a 95% confidence interval for the population mean rent for Los Angeles and interpret. And the question I have really is, what type of problem is this? And this is a confidence interval of a population parameter. In this case, the parameter is average rent I'm going to abbreviate LA County as LACO. And I'll show you the keyword how you know it's a 95% confidence interval. Right there, it says a 95% confidence interval. Okay, so let's talk about what confidence intervals look like. All confidence intervals will look like this. They're an estimate plus or minus a margin of error. So it says all intervals will contain a confidence level. This is the probability the interval will capture the true value of the parameter in repeated samples. So much like probability and other things, we're looking for repeated, or looking for things that occur over time. So I'll give you a second to copy this down, and then I'll go on to the next slide. Okay, and here's my 4 steps. It's state, plan, do, and conclude. And since you can read this on your own, I'll give you a second. You might want to pause the video to write this down. Just so you know, number 1 is state, number 2 is plan, 3 is do, and 4 is conclude. So I'll give you a second to copy this, and we'll go on. Okay. And here's the confidence interval. I know it says for mu, but let me put it for a z. Because we're going to talk later on about a t. Well, that's actually chapter 11. And it says x bar, we know what that is, plus or minus z star sigma over the square root of n. And the sentence stem down here you're going to want to write down. It says we are blank percent confident that the true, and it says parameter, because when we write it out we're not going to use the word parameter, but we're going to say whatever the parameter is. Now the parameter for this problem was average rent for Los Angeles County. So for this problem we would say we are 95% confident that the true rent for Los Angeles County is between this value and this value. Okay, so let's talk about this. X bar. X bar is our mean of a sample. We know it's a sample because X is a Latin letter that we use to write every day, or a Roman letter. So X bar plus or minus Z star, which we'll come back to, and sigma over the square root of n. So your Z star, that's what this is called, by the way, is Z star. This tells us how many standard deviations from the normal we are. So if we had a normal distribution, in this case we're 95% confident, so it's the middle 95%. That's a lovely 95. Well, let's just say 0.95. We know that there's 1.6 standard deviations. And the way we find our z star is we look at the very back table in our book. It's a t-chart, and the bottom line, it'll either say z star or it'll say infinity. And it'll have a confidence level. And that's table C in your book, which is the very back of the book. Not the last page, the actual back cover of the book. If we look on there under 95% for the confidence interval, we find out we get a z-score, or z-star rather, of 1.96. Okay. So I'll give you a second to copy this down, and then I'll go on to the next thing. Okay, here are the conditions for the interval for mu. And again, I'm going to put a z because there's a z and a t. And there's 4 conditions. I'll let you write them down. Okay, if you haven't written them down, then pause the video for a second. So it says here, if all the conditions are not met for any test, PWC, which means proceed with caution, and we'll let it be known. So I'll read the conditions, remind real quickly what it is. 10%, we cannot sample more than 10% of the population. SRS, we want our sample to be random, and the reason for that is we don't want any bias, or we don't want one event to influence the next one. No sigma. In order for us to use this test that we just talked about, the z-star, we absolutely must know this. We cannot PWC on number 3. Number 3, if we don't know sigma, it will not be a z-test. We absolutely have to know this. And then must be normal or CLT. And again, CLT is central limit theorem. So this is the end of the notes for this video. The next video I will walk through how to solve one of these problems, the problem we just saw with USC, and that should help you out a little bit with that. Good luck.